Here in these next couple examples, we're just going to be analyzing quadratics a little bit and just talking about the nature of these things and how they work and how to compare certain features of these. And so if we look at something like this, it says the path of a rocket, rocket A is modeled by the equation h equals negative 16t squared plus 150t plus 1, where t is the time in seconds and h is the height in feet. And rocket B is modeled by the graph below. And the question is, which of these things flew higher? And so when we talk about, the structure of these things and we start talking about parabolas, when you think about the vertex of a parabola, the vertex is really just the highest or lowest point. It's the maximum or minimum. And so if we want to know which one flew higher, we need to compare the y values of their vertices. And so when we look at something like this guy, first let's look at the equation. If we look at the one that's modeled by the equation, which is this guy up here, we want to talk about the vertex of this thing, so I need to find the vertex. And so really just interpreting this thing, knowing that we're talking about the vertex first is really the most difficult part of this. After that, we find the vertex the way we always have. I do the opposite of b over 2a. So opposite of b is a negative 150 over 2 times a, which is a negative 16. And really this becomes a job for my calculator, as long as the decimal here is not too messy. We can just leave it that way. I don't think it should be. Yeah, it gives us a decimal that does end. I get a 4.6875. And then from here, we just have to plug that thing back in. And obviously, I wouldn't recommend plugging this in your head. We're going to plug this back into our equation. So we're plugging this guy in for x because we want to find the y value. When we think about interpreting this thing, really what we've found is how long it takes. We've found the time that it takes to reach the maximum height. Well, now I need to find out what the maximum height actually is by plugging this thing in. So I plug this into my calculator. And when I do that, it looks like I get 352.5625. And so again, thinking about interpreting this thing, that's 4.6875 seconds to reach 352.5625 feet. Okay, I guess I won't include the units there, but understanding what that means. And so now when we look at this other one, there's not much of a comparison here at all when you think about this. You look at this graph that's given, and even though we can't identify the exact vertex, it looks like it travels for about 6 seconds. It looks like somewhere around 6, and then somewhere around maybe 575. And so when you compare these, obviously rocket B travels much higher in terms of that y value. And so again, it's understanding we're talking about the vertex here, and then comparing the values of those vertex and understanding what they mean. And that's it. If we look at the next one's a pretty tricky one. So last year at Mr. Jansen's Clown Emporium, we sold 500 rubber chickens. And obviously this is made up. I don't own a Clown Emporium, but if I did, I think the rubber chickens would be the hot commodity item. And we sold them for $10 each. It's estimated that for every $1 increase in price, we're going to sell 20 fewer chickens. And then we want to know what should the price be to maximize the income. We want to make the most money out of this thing as we can. And when you think about it, obviously, yeah, if we increase the price, less people are going to buy. All right? We'll make more money on each chicken, but we won't sell as many. If we decrease the price, we won't make much on each chicken, but we'll sell more. And so we kind of have to find where that balance point is. And so I have to think about the situation. So we're going to think about the cost of each rubber chicken, how much we're going to sell them for. And we're also going to talk about the number sold, okay, how many we're going to sell. And so we start with the information given. I know that we sold them for $10 last year, and I'm going to increase the price. So when we look at the cost, I'm going to take $10 and I'm going to add to that, and I'm going to add $1 increments. So I'm going to say 1 times however many increments, I'll call it x, that I want to add. And so the variable that I'm using here, x, is the number of increases. And again, those are in dollar increments. So, if I decide to increase it by 1 increment, it'll be $11. 2 increments, it'll be at $12, okay? And then I do the same thing with the number sold. Last year it was 500, but I'm going to lose customers for each increase. And it says I'm going to lose 20 customers per increase, so minus 20x. And so I'm writing equations for each of these things. Now, if I think about how much money I'm going to make, I take how much I'm selling it for times how many is sold. Like if I ask you how much money did it make last year, everybody looks at it and says, okay, you sold 500. They were $10 each, 5,000. We multiply. And we do the same thing here. I take how much they cost, which is this guy, times how many I'm going to sell, which is now this guy, and I multiply them together. Okay, this is going to tell me, what model I'm following. And when I multiply this out, again, this is going to give me, that's going to be 5,000 minus 200x plus 500x minus 20x squared. And now if I just rewrite this a little bit and simplify, I've got some like terms here. I'm going to put it in a different order. That's, oh boy. Sort of my pen went a little bit squirrely there for a moment. Having trouble writing. Let's see, that's a negative 20x squared plus 300x plus 5,000. And so when we look at something like this guy, it's a quadratic. It's modeling a parabola. So if I want to maximize my income, that's what this thing is describing. I'm essentially describing my income here, which I can call y. And so y is basically how much money I'm going to make. X is how many increases I should make on this thing. And so what I really want to find here is the vertex. And then I have to interpret that vertex. So to find the vertex, I'm going to do the opposite of b over 2a. And again, that's a job for my calculator. And so when I plug that in, I get 7.5 here. So that's telling me how many increases I should make. So the question was, what should the price be to maximize the profits? And the price shouldn't be 7.5. Again, that's the number of $1 increases. You have to plug that back in up here for the cost to find out the price. And so the price of this thing, when I do the 10 plus, $1 times 7.5, so I'm going to do 2.5 $1 increments to increase by. That's $17.50. That's what I should sell each one for. But then it also asks me how much more will be made this year. Well, if I want to find out how much money I'm going to make, well, I got to plug that guy down into my equation, because this is the equation that was describing how much money I'm going to make. And when I plug that in down here, again, that's a job for my calculator. I get 6,125. But that still doesn't quite answer that question. It asks how much more I was going to make, so I have to think about how much I made last year. And last year, we already said earlier that I made 5,000. So now I'm looking at the difference in price. I'm going to make more money. I'm going to make $1,125. And really, hopefully you can see the power of this. When you think about it, I've done very little work. I've done a little bit of market research to figure out what people are willing to pay for this thing. And so with a little bit of market research and a little bit of a calculation here, I've instantly made over $1,000 more than I would have. Okay? And that's where these things really come into play and really come in handy in terms of a real-world context. All right? So to answer these two questions, I should sell them for $17.50 each. And if I do that, I'm going to make $1,125 more than I would have last year. Okay?